This is section 4.3. We can do 4 problems here, 4, 5, 6, and 7. Number 4 says there are 8 wires which need to be attached to a circuit board. A robotic device will attach the wires that can be attached in any order, and the production manager wishes to determine which order would be fastest for the robot to use. Now, use the multiplication rule, so we're just going to multiply here, to determine the number of possible sequences of assembly that must be tested. Okay, and then they tell us, all right, now, there's 8 choices for the first wire. Let's just do this. This is just going to be what? It's going to be, all right, how many choices for the first wire? 8 times. For the second wire, 7 times. For the, okay, 7 for the second wire, 6 for the third. What was that? 6 for the third. Okay, the wires can be attached. Okay. Well, then it says etc. So I guess what it means is there's 8 choices for the first wire. Yeah, all right, there's 8 wires. So you have 8 choices for the first. Then you use 1 wire, so there's 7 for the second. Then you use 2, so there's 6 for the first. So this just comes out to 8, 7, 6, 5, 4, 3, 2, 1, which is exactly 8 factorial. Do it on your calculator, or just, you could do this on your calculator. Type in 8, go to math. So you press the math key. Now the math key is in the left column. So you press math, and then you have to arrow over to PRB, probability, and you select item number 4. So you can scroll down or just press the numerical key 4, and the exclamation point comes up. And so you're looking at 8 factorial on your machine, so just press enter, and here's what I got for it. I got 40320. All right, so in here, I'm up here now. I'm up here on the left where I'm going to input the answer. I am going to put in 40320. So there's 40,320 possible sequences. Problem 5. Barbara is a research biologist for green carpet lawns. She's studying the effects of fertilizer type, temperature at time of application, and water treatment. Okay, she has 6 fertilizer types, 3 temperature zones, and 5 water treatments. Determine the number of different lawns she needs to get them all. Okay, so this is straight multiplication. This is going to be what, let me get it to right, 6 times 5 times, no, 6 times 3. I got them out of order. The order doesn't matter, though, fortunately. 6 times 3 times 5. All right, so we've got 18 times 5, or 15 times 6. So I will put a 90 in there and claim that that's my answer. Number 6, toss a pair of dice. Determine the number of possible pairs. Okay, so there's, what, you toss a die, one single die, there's 6 possibilities. There's 6 possibilities on the other. So you have 6 for the first choice, 6 for the second. So this is going to be 1 over, okay, just determine the number of possible outcomes. So I think this one is going to be, 6 times 6 is 36, right? I got it by doing this, 6 times 6, all right? So 36. Second part says there's 3 even numbers on each die, right? 2, 4, 6. How many outcomes are possible with even numbers appearing on each die? All right, well, there's 3 choices for the first, 3 choices for the second, so I'm thinking there's 3 times 3, so I'm going to put a 9 there. And then we're asked probability extension. Must be hard. Let's see. What's the probability that both dice will show an even number? All right, now we want a probability. Well, look, there's 36 possibilities, and you want both dice having an even number. There's 9 ways to do that, so it looks pretty straightforward. I think it's going to be 9 over 36. So how about 1/4? It says round to 2 decimal places. Okay, that's 1/4, which is 0.75. And in number 7, compute the number of permutations, 7 objects, 2 at a time. All right, we have a formula for this. permutation of n objects taken r at a time is, okay, total number of objects factorial divided by n minus r factorial. So for us, this is going to be, all right, we have permutation of 7 objects, 2 at a time. So this is going to be 7 factorial in the top and a 7 minus 2 factorial in the bottom. That's 7 factorial over 5 factorial. Now I can do a little bit of reducing, right? I can reduce this by taking that top number, breaking it down until I get to the bottom one. So I can write it like this. 7 times 6. Now what's left? 5, 4, 3, 2, 1, which is exactly 5 factorial over 5 factorial. Those cancel. I get 7 times 6, which is 42.